As I said to you, neural networks is a network of neurons. We have some inputs, some outputs. Here in this figure, I have just one output. And some weight or some W's in we have some W's on the edges, and we have activation function in all neurons. Every of these neurons can be, for every of these neurons I can write a equation. The output is a function of a summation of Wi in xi. So I say it again, the output of neurons is a summation over the weight in input. And we have an activation function. This activation function has a very important role in neural networks, but for simplicity, sometimes when people want to teach neural network, sometimes they assume that they have no activation network, or they can say that the activation network is f of x is x. This is something that is assumed in the video that you see at first. This is just for simplicity. They have used this assumption, but normally activation function are defined in the your neural network. The topic of neural network is, do you mean that this is new for us in this class? I have talked about it in the past week, I think, in a slide. But I think this is new. Yes, this is new for us in this course. Anyway, we will talk about the structure later. But now, I want to give you an problem, and we will solve this problem together. Okay. Assume that we have a table of A, B, C as input and F as output. And we have some numbers here. I have an example of this in an Excel file. You can see this. This is A, B, and C, and this is output F. the output is 0 or 1. Here in this example, I have 5,000 of rows, for example, about 5,000, and we will talk about the Excel file. Okay, this is the function that we have in the function, or the I'm sorry. Function, or we can say this is a classification problem. In classification problem, the output is limited to some values. For example, here output is limited to 0 and 1. This also classification function can be casted also as a classification can be also considered as function because it has some inputs and outputs. Okay, assume that we have such a table and we want to train and test a neural network. This can be numbers of a problem of, for example, problem of orange and apple. Do you remember the example? We had an example that we want to separate orange and apple. We had an example in the past weeks. We wanted to separate orange and apples, and we wanted to use a neural network for this separation. We have extracted three features from apples and orange, and we name this A, B, C, and the output F, for example, it is 0 for orange and 1 for apple. So let me say it again. We have a database or an Excel file. We have a database. This column D here is the output of our function that shows that this is apple or orange. Here, for example, 1 is for orange and 0 is for apple, or A and B and C are features of apples and orange that we have here. Now I want to ask you a question. If you have collected such a database for your project, you're typing something, let me tell you again, assume that you want to solve the problem of orange and apple as your student project. You have a student project, okay, and you want to do the project by neural network. What do you do for your student project? At first, you collect this data set. For example, you collect a data set from hundreds of orange and hundreds of apple. For this project, again, for this project, you collect data from hundreds of orange and hundreds of apple in this form. So we have 200 lines of data. We have 200 of data. The first three field is x1, x2, x3, three different features, and the fourth column, or the this field is the class field, or something that shows that it is orange or apple. This is the first step. So the first step is making this data set. And what is the second step? What we will do after making this data set? In your student project, after making data set, the data set here is a table of 204 is the table. After making this data set, you should separate this data set into parts. We name say that this is 200. We name the first part as training set and the second part as test set. So again, I repeat this. In the second phase of your student project, you separate your data set in two parts, a part of training set and a part of test set. For example, you say that this 150 of rows is training set and 50 of rows is test set. And we name set this three first column as input training set and this output training set, and this is input training set, input test set, and this is output test set. Okay, low sound. I try to talk loudly, but we do not have hundreds of features. We have three features. Okay, we have three features here. We have three features, and we have hundreds of sample of for each class. We have 200 samples. 200 samples. 200 samples. 100 apple and 100 orange. I want to say it again. You want to do a student project. You want to do a project to know to separate apples and orange. Okay. In order to do this project, the first thing that you do is to collecting data set. You collect data set from these hundreds of apples and hundreds of orange and make such a table. After making this table, the second phase is to distinguish this data set into parts. The first part we name this training set, and the second we name this test set. But training set and test set have input and output. The first three columns was input and the fourth was output. Okay, so we have three features and we have 200 of samples here. Again, have a look on our data set. we had, if I name this A, B, C, and D, A is input train set, B is output train set, C is input test set, and D is output test set. So what is the next step? Now, if you want to use neural network decision tree, if you want to use Bayesian network, you should choose your model, and no difference which model you use. These two steps were the same. The first step and the second step, you have these for all classifiers. But now, after choosing the model, we should learn our model or train our model. How we train our model, it depends to the model that we use, that we have chosen. For example, if you want to use neural network, you should adjust the weight or every other model have its own properties. Okay, now in the next step, I want to train the model or learning model. Learning of model is done by training set. Again, what we do, we make our learning, we do our learning by training set. I set my model such that I can find B using A. I want to make a function to be able to receive from A to B. In neural networks, in this example, I have 150 of rows here and 50 rows here. In neural networks, in this example, I have to use 150 of rows to train my model. I mean to set this weight, and after that, so it was the third step. The third step was, or the third step was training. Data set, training model. The third step is training model. For example, in neural network, by adjusting weight, we can train model. So let me review the steps. The first step was collecting data. The second step was separating data in two parts, training and test. In this example, I said that I have 150 training and 50 of test. And the third step was model training. Model training is done by training data, in this example by 150 of rows. After that, you trained your neural network. You have to test it. When you train your neural network, you have to test it. How do we test our model? We can test our model by test data. Okay, we test our model by test data. If we want to learn this correctly, we have to make an example. By example, we can see that how this works. Okay, so I want to give you an example of this process by real numbers, and I want to make a model and then testing model, and we will see it practically. But before that, let me give you some instruction in MATLAB to be able to test this. In MATLAB, we can implement neural network. We have different instruction for neural network. One of the most famous and one of the oldest instruction are NewFF, train, and sim. These are functions in MATLAB for training and testing. For training and testing neural networks. For this problem, if you want to make a model by neural network, we have to write such a instruction. We say, for example, net. This is a variable. Net is NewFF. In NewFF, we write the matrix of training, NewFF AB. And again, we say that net2, for example, is equal to train net AB. So look here net2 is an trained neural network. Net is a neural network, and net2 is a trained neural network. Are you in class? And do you follow the course? Do you hear me? Okay, thank you. I want to give you example to be able to understand this better. So please take care here for me. I will write this in MATLAB environment, and we will check this together. The first instruction is new FF. This is a function in MATLAB for making neural network. FF is stands for feed forward. New feed forward. This is a type of neural network that is the most general form of the neural network. Okay, net is equal to new FF A and B. It makes for me a network with the correct number of inputs, correct number of outputs. New FF makes or network using the size of A and B. So new FF make or neural network. We can also say in this instruction, we can say that how much I want to add hidden layer here. I can give some other argument to this function to say that how many hidden layers I want, which type of activation function I want to give to this, and other parameters can be set here. But if we do not use any other parameters, new feed forward will give them default values, and for the first example we do not use other arguments. Again, what does new FF do for us? New FF make the structure of network. I mean, it just makes the structure. The weight is not set in this function. The next function train, this function set our values, give values to the weight such that we can receive from A to B. We have another instruction that is sim. Sim, S-I-M, sim. In the function sim, we give the model to sim and matrix of inputs, for example, C. Sim, if I give C to network, to the neural network, I expect to receive something which is close to D. I name this E. Have a look here. Sim is a function that we can give the output of every input to neural network. For example, I can say that what will be the output if I give this tree feature to neural network. Again, have a look. This is not very difficult. I have instruction new FF for just making the structure of neural network. I have the function train for training this neural network, and after all, we have the function sim for testing neural network. If I give a matrix of input to neural network, it will give me a matrix of output. We are very successful in this training if I can say that E is equal to D. If I say that E is equal to D, I can say that we have a very nice and good neural network. But normally E is not D exactly. We have differences between E and D. I want to make D by this function, but normally we can say that we have exactly D. Okay, so we have some error. What is error here? Error is the difference between E and D. The thing that I want to receive, and something that I receive really. The difference between these two is error. Let me write this again. We add new FF A and B. I said that E is close to D. E should be close to D. If E is, if I can say that E is equal to D, this is, if I can say this, I say that this is a ideal neural network. But normally this is not equal, and we have to we always calculate the error by comparing D and D. I want to ask you a question. If I say that F is sim net 2, excuse me, it was C. And A. I said that E should be close to D because E is the output for the input C. But here, have a look. Sim is F is the output of network for input A. I expect that F, I wish F is equal to A, to B, excuse me. I expect to have F equal to B, but normally, yeah, there is some differences between F and B. I want to ask you a question. Which one is closer? E is closer to C or F is closer to B? Which one is, if I can write, which one is less? E, the difference between E and D, or the difference between F and B? Which one are closer together? Again. Let me review again. We had a model. Model is neural network here. I trained my model by A and B. Okay, I trained my model by A and B. What is the meaning of training here? Training is to set this model in order to have B using A. We are trying to have B using A. It's 150 rows here. If I give the first row, if I give this and this and this, A, B, and C, if I give A, B, C of the first row to the model, I will receive the first row of B in the output. I'm trying to do this. I'm trying to do this. If I try to do this, I say that I'm training the model. Okay, again, the first, at first, after collecting data set and separating data set, in the third step, we learned our model. And now, after learning our model, we want to test this model. Okay? For testing the model, I give C to the model and I get E. I give A to model and I get F. I wish, I want to have E close to B and F close to B. If E is equal to D, I say that this is ideal. Or if F is close to B, I say that this is ideal. But normally this is not true. We can't say, in most time, we can't learn our model such that we can receive exactly to the output that the real output. What did I ask you? I said that which one is closer? E is closer to D or F closer to D? In other words, of course, these are vectors. It's not numbers that we simply write a minus, but assume that this is a single value. Which one is less? Which one is closer to 0? B minus F or D minus E? Normally, I mean, usually, answer me usually. In usual, which one is less? Let me give another definition. The difference between D and E is error. Difference between B and F is also error. Both of these are error. But this is error in the test set. We name this testing error. And this is error in the training set. We name this training error. We have two types of error in model: test error or error in testing data or error of training data. Which one is less? training error or testing error? Which one is less? Okay, let me see your. You say that model must to make input of the output B and C. The input of output D, that is true. I just want to check that we understand this until here. For our training set, for our data set, we separate data set to two parts: the training data and testing data. We trained our model by training data, and we can test our data by our model by testing data. In order to test our data, we give C to our model, and we expect to get D from model. But if we give C to model, we receive an E which is not always equal to D. After calculating the difference between D and E, we say that we have a test error equal to, for example, D minus E. And this is the training error. Training error is difference between B and F. I ask you usually which one is less, training error or test error? If you do not ask, test error is normally more than training error. Training error is usually less than test error. Why this is less? Why training error is less? Because training error is the error of the error that is that we calculated by the data in training. I mean, I learn my model to make B from A. So I expect to I receive output very close to B. Normally, training error is very lower than test error. Again, why this is less? Because the model is made by A and B. I have made my model by A and B. So I expect to have the output of E very close to B because I made the model by this. But this is another part of data set that it was not in the training phase. In training phase. In training phase, we just had A and B. So the train error is more, test error is more than training error. But when we train our model, mostly we check training error, and we try to calculate this training error as an evaluation as the evaluation of or model. Okay, I write it. Let me write the program in MATLAB. After that, we will go to we will go back and we will review all this. In MATLAB, I want to train a neural network for this data. Here we have A, B, and C for x1, x2, x3, and this is F or output of the classifier, output of neural network. I just choose 200 of this. We have 200 of this data here. In MATLAB, I can read data from an Excel file. I have to see this A, B, C, and D. Do you see the fonts? A is training input training set. Let me read data from Excel file. First, data is XLS read let me find the path. Do you see this? The thing that I'm typing. XLS read is the function in MATLAB for getting data from Excel files. Okay, so I use this to read my data from Excel files. I should give the name and the path of file, the Excel file, as the first argument of Excel read, and the name of the sheet. Here it is sheet 1. The name of sheet as the second parameter. So this is the data that I read from Excel. And I say that A is data is the first 150 rows of the of 100 of the 200 rows of data, 150 rows, the first 150 rows. We say that this is 1 to 102, and the first 3 columns. Let me check to see that is this true. If I run this, let me check what is the problem here. I think this is I don't know what is the problem in my file, but let me copy the data to another file to be sure that there is no problem. Excuse me, I just want to check check the data in another file. Yes, it's true. Okay, we use XLS for reading data from Excel file, and now I say that A is the first 150 rows and the first 3 columns, and B is data again 1 to 150 and the 4th columns. And C is data from 51 to from 151 to 200, and column 1, 2, 3 and D is data from 151 to 200 and column force. This is just to make our input training set, output training set, AB, input test set, and output test set. Now I want to train my network by new FF. Do you see what I'm typing? Are you here in class? Do you see? Yes, okay. Okay. So here, thank you, yes. At first I want to use new FF. In new FF, I should give A and B to make the structure of my neural network. Normally in new FF, I should give A and B. Why do I use this? So net is the structure of my neural network. I say that net 2 is train net and A and B. Now my here I have trained my neural network. So I just want to test my neural network. I said that E is sim net 2 and C. This is what will be the output if I give C as input. And F is the output if I give A as input. Now I have to calculate the difference between E and D and the difference between B and F. But let me have a look to see about dimensions. I have to repeat the A and B again to see the dimensions. The dimension of A is 150 in 3. Dimension of B is 150 in 1. Dimension of C is 50 in 3. And this is 50 in 1. Normally, if I want to give the data to neural network in MATLAB, MATLAB accepts data in this form. A should be, for example, should be 3 in 150. I have to transpose network the data A. Each rows, each columns is given to neural network as input and output. So again, this is just because of the format that new FF accepts from me. I have to transpose A and give this to to give this to the function new FF, and the output that it gives to me is a 1 in 150. The output of new sim. The output of sim is, for example, if I give A to sim, I will get a vector in 1 in 150. This is why that I used A prime instead of A. If you look here I said that net is equal to new FF A prime and B prime. And in train, I also used A prime and B prime. And in sim, I get C prime and A prime. Sim is a function that gives me the output of any input set. Okay, for example, here when I say sim net to C prime, it means that what is the output of net 2 if I give C prime to net 2. Okay. If I give C to the neural network, what is the output? We use this. We find this the solution by sim. Sim gives me the output of every input that I want. Here in this example, I have given C prime. C prime is 50 of 50 rows of inputs. I gave C prime to a network, and the sim calculate me the output of neural network for this for C prime. And here I have given A to a network, and I receive F. What do we expect now? I expect that have E very close to D and F close to B. A prime. This is why that we use A prime instead of A. This is the this is the feature of new FF. In new FF accepts data in this form. New FF, if you want to give, for example, if you want to give A and B to new FF, you should give A in such a form that each column is data. I mean, you have to transpose A. We have to transpose A and transpose B to have the form of to form to have the form of new FF. Okay. We could if our data had let me open the Excel file. This is our Excel file. If you can do this, okay. If we save our data in this form, if we save our data in this form, you do not need the transpose in MATLAB. Okay. This is transpose in MATLAB. If A is, for example, I gave myself 1, 2, 3, 2, not A. If I define M is 1, 2, 3, 2, 1, 5, M prime is 1, 2, 3, 2, 1, 5. Why do I transpose this? Because new FF accept this type of data. Okay, so I transpose this. If I save this, I can write, I can read my data from sheet 2 instead of sheet 1, and then I do not need this transpose. Okay, again, why did I remove this transpose? Because now I have the data in the form of new FF. In new FF, they assume that each column is the data of a sample. Okay, so no difference. You can have your data in this form and use transpose, or you can have your data in this form and do not use transpose. This is the specification of this MATLAB function, and it's not related to the data. This is close to iftar in Iran, so I can't give you a break. I will finish the course soon. Just let me run this program once, and we will finish the course. Let me do a run. Okay, we can have a break because after changing this, after changing the data, I have to modify A, B, and C, and D. I give you a break, and please come back in 5 minutes. Come back in 5 minutes, just 5 minutes. Okay, but in this time I correct my data, because when I made the transpose in data I have to change all this. This is the break. No problem. Go and come in 5 minutes. Okay, it was just a break. It was not finishing the class. Are you here? Okay, let me continue. We had the example here. We made A, B, C, and D. No, I just corrected A, B, and C, and D, because when I make a transpose on data, I have to make transpose on all A, B, C, and D. This is not very important, but I've looked here to see what happened. I copied my data from sheet 1 to sheet 2, and I made it. I made a transpose to be in the format of MATLAB, format of new FF. Okay, and here I have A, B, C, and D, and this is training model. This 2 is for training model, and this is for testing model. Now I want to compare F and B. I want to compare between F and B. But if you see here, I have written the value of F here. This is the value of F. You can see value of F here. Value of F is in this type of neural network, the values is, for example, you can see that this is 0.1439, 0.8711. Okay, but in our data, the output is 0 or 1. If you remember, our data is 0 or 1. So here I use the an if, for example, I say that for I is 1 to length of F, if F and this, if F A is less than 0.05, Fi should be set to 0, else Fi should be set to 1. Another time, have a look. F is a vector of 50 of excuse me, F is a vector of 150 of numbers, but F should be 0, just, or 1, because this is the output of classifier. Okay, so I write this condition: if Fi is less than 0.5, set Fi as 0, otherwise set Fi 1. We repeat this for E. Okay, and no, E and F are 0 and 1. Now let's have a review. We had B with some zeros and 1, and F with some zeros and 1. How do you compare these two? We can compare this by some ifs, and we say that if these are equal, this is true, and if it is not equal, this is wrong. Or in MATLAB we can use this function f minus b, and we can use some functions in MATLAB. For example, ABS of f minus b gives us a vector of 0 and 1. If f and b are equal, this will be, if f and b are equal, this is 0, and if these two are not equal, this will give me 1. So here I write error 1 is sum of ABS of f minus b, and error 2 is sum of ABS of E minus D. And finally, I want to write error 1 and error 2. Excuse me, why don't set I is less than 0.5? I said this, I is less than, not I, but f of I is less than 0.5. Yes, we just want to set our data or values to 0 or 1, because this is classification. In classification, I just have values 0, I just have some special and determined values. Okay, here we had 0 and 1. And what is these two? What is these two? Error 1 and error 2. I just want to see the difference between I just wanted to see the difference between E and D and F and B, so I calculate this. Let me save this because my charge is going to be finished. My course is over now. I'll send the video and this code to you, and we will talk about this code in the next lecture. Have a nice time, and I wish you are okay and well. ABS, no, ABS is a function that absolute value, قدر مطلق. If the value is, for example, ABS of minus 10 is 10, ABS of minus 20 is 20. Here, because if I use f minus b, I will receive 0 or 1 or minus 1. Okay, if you use f minus b, you will get 0 on 1 or minus 1. So I use ABS to give me just 0 and 1. I want to see the difference. If f and b are equal, if f and b fi and bi are equal, so this I will get a 0. If fi and bi are not equal, I will get 1 or minus 1. ABS is to convert this 1 and minus 1 to 1. And some count number of ones in this. This is the property in MATLAB.